Many are screening their own inventories with handheld XRF devices. This method is effective only for screening large areas of the board for gross violations of the RoHS limits. In an article by Rob Spiegel titled, "Testing for Compliance Heats Up," Jeff Schaefer, Senior Vice President of Product at Newark In1, says, some companies have a gun, and they point it at the component and it will say that bromide is present. So they're rejecting the component. But the test cannot identify whether it's banned substance. Some bromides are fine, others are not. Also, the testing beam emitted by the handheld XRF is not small enough to test the solder joints on most IC package types. As a result, it factors in the area of the board surrounding an IC when calculating elemental content levels. This can skew the results. In order to get a more precise reading for an individual component, a smaller test area or collimator is needed. OEMs who are using handheld equipment as a final analysis may be acting on inaccurate results. A desktop XRF machine can solve this problem because it has a smaller collimator, and the sample to be tested is secured on a fixed platform. OEMs who are screening their assembled PCB boards for RoHS compliance violations are performing a necessary step of their due diligence obligations. However, when converting components, it is important to receive test results from the conversion laboratory stating RoHS compliance of the converted component. These tests should rely on either destructive testing or a desktop XRF machine screening which can pinpoint smaller areas on the components, such as the termination finish, to verify that a proper conversion was performed. There are also some key factors to ensure that the XRF screening is performed accurately. Let's take a look at some XRF technical requirements to see what's needed to test for RoHS compliance on converted components. It is important to have a sample at a fixed distance and for a period of no less than 1 minute to obtain the 1,000 parts per million level of accuracy needed for RoHS compliance. Only a properly calibrated desktop XRF machine can do this, which enables it to detect the RoHS elements with the accuracy needed for such low-level detection. This is not as easy as it sounds, the key being a proper calibration and a specific program that defines the elements searched for. Contrary to some beliefs, a desktop XRF machine is not as turnkey as it may sound when it comes to RoHS testing. While it is true that it can detect to the approximate percentage of lead in a sample on an out-of-the-box, standards-free calibration, several extra steps are needed to determine all RoHS restricted elements and their precise values. First, a proper calibration through use of reference foil standards is needed to fine-tune the instrument to be able to detect with the accuracy required by RoHS limits. Secondly, you need to tell the machine exactly what it is looking for through the use of a program that defines the characteristics of the spectra involved and distinguishes between them. Then you must cross-reference the machine against test items that you know the value of, preferably obtained through destructive analysis. Finally, it is important to perform a matrix of tests to determine that the levels detected are repeatable and accurate. Only with this criteria, as well as an XRF technician with proper training and experience with spectrometry related to RoHS, can one achieve the desired level of accuracy needed to determine RoHS compliance.